Welcome back. My name is Gregory Carlson. Let's finish this example. So this is going to be up here if we do the distributive property, minus 4x minus 4h. Do you agree with me on that? So 4x cancels with negative 4x. And so if I rewrite this, the limit as h goes to 0. Now remember my trick on this. This over h is the same as multiplying by 1 over h. So on the top, I have this negative 4h. And on the bottom, I still have x times x plus h. So that's just this top fraction. We have negative 4h over x times x plus h. And remember, instead of dividing by h, I'm just going to multiply this by 1 over h. Because then it's a lot easier to see that this h cancels with this h. Do you agree with that? So the limit as h approaches 0, now that we got that h out of the denominator, I think we're about ready to evaluate the limit. So here's what we got. And now if I take the limit as h approaches 0, it's not going to wreck anything. So let's do that. This h right here goes to 0. And so we get negative 4 over x times x is x squared. So the derivative, f prime x, is equal to negative 4 divided by x squared. That's really cool. So the instantaneous rate of change of the entire hyperbola function, not just this part, but the entire thing, can be given by the function negative 4 over x squared. So that's really remarkable. So by the way, do you notice any relation between this and this? I'll let you think about that. Let's evaluate the derivative at 0 and 2. So if we evaluate the derivative at 0, we see that f prime of 0 is going to be negative 4 over 0 squared, and that's bad. That's undefined. In a way, that's actually good, because remember how we needed it to be undefined, because the graph's not defined right here, so how could it have a slope? And so it turns out the slope at 0 is undefined, so we're okay. Let's evaluate the derivative at f of 2. I just plug in a 2 right there, and I get negative 4 divided by 2 squared, which is negative 4 over 4, which means that the derivative at 2 equals negative 1. And that's good, because remember, so the derivative at 2 is equal to negative 1, and remember how I said we should have a slope of negative right there, because that's what it looks like the tangent line is, and it turns out that slope is negative 1. So that's how you would find the derivative of a hyperbola using the definition. Let's do the next one. Find an equation for the tangent line to the graph at this function here. So this problem is a little bit trickier than the ones we've done so far. If I just graph this really quick, because it's just a hyperbola that's been bumped up it's a parabola, excuse me, that's been bumped up 2 places, so it looks like this. And one of the points on the parabola is right here, and that point is 311, right? So, and you can plug in 3, and you get 3 squared is 9, plus 2 is 11. So 311 is a point on our function. And this time, they don't want to know what the derivative is. They want to know the actual line, equation of the line, whatever it is, that goes through that point. So they want the actual equation of that line. So that's going to add one extra step to this, okay? So let's do it. So first, let's find the derivative. That's equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, if it's okay with you, I might skip a few steps here, so if you have any questions, just ask them in the comments. This is going to be x plus h squared plus 2. So that's going to be x squared plus 2xh plus h squared plus 2. All right, do you agree with me there? F of x plus h, if you plug in x plus h right there, this is f of x plus h. So now we're going to subtract f of x, so subtract x squared plus 2 in parentheses. and that's all over h. So this is negative x squared minus 2 when you apply that negative sign. So x squared cancels with negative x squared. 2 cancels with negative 2. So we get, now, what do I have left? I have 2xh left, and I have h squared left. And that's all I have left. So I need to get rid of the h out of the denominator. So we'll factor out h out of the top. Like that. So I just factored h out of those two terms. This cancels with this, and now it's great. Now we can evaluate the limit as h goes to 0. And so this h goes away when we evaluate the limit. Now, I should actually do that in 2 steps, because it's important that you realize I canceled these 2 h's before I did the limit. Okay, I haven't evaluated the limit yet. So I have this. And I'm sorry, I'm off the screen. So I haven't evaluated the limit yet. I canceled these h's. So now we're here, and this is all over 1 now. Now we evaluate the limit. So now this little h goes to 0. And so we get f prime of x, the derivative, is equal to 2x. That's interesting. When we found the derivative of x squared just by itself, the derivative was 2x. And it seems like when we take the derivative of x squared plus 2, we get the same thing. It's almost like shifting this parabola up 2 spaces didn't affect the derivative. Wait, that makes sense. Doesn't it make sense that if you just bumped the entire graph up a few spaces, it wouldn't affect the slope of the graph? We'll talk about that more later. So there's the derivative. That means that's the slope of this line everywhere, whatever x value you want. Now they want the graph of this equation. And to get that, you're going to need to use the point slope formula, which hopefully you remember from your algebra class. It is big Y minus little y equals m times big X minus little x. That's the slope formula. We know what the slope is, and we know that a point on the graph. We know that the point we're looking at is 311. So here's what you do. You do y minus 11. Of course, I wrote equals. So y minus 11 equals, I'm not going to write our slope yet, x minus 3. So that 11 and 3 come from the facts that we're going through the point 311. Okay, that's where that came from. So now what is the slope? Now remember, here's our slope formula, f prime of x equals 2x. So we're at the point 3, so I just plug in a 3 right there, and I get that f prime of 3 is equal to 2 times 3, which is equal to 6. So the slope of my line is going to be 6. Does that make sense? To find the slope of a tangent line, you just need to plug in that x value into your derivative function. So now let's just simplify. Y minus 11 is equal to 6x minus 18 after you do the distributive property. And then finally add 11, add 11. So the answer they're looking for is 6x minus 7. So you can see that my sketch was a little bit off. It should be a little bit steeper with a y-intercept going through negative 7 down there. And so that's the actual equation, y equals mx plus b, of this exact tangent line of the graph hitting the parabola at 3. Just to recap, first we went through all of this just to figure out the derivative function, which tells us the slope wherever we want. Then we used the point slope formula, big Y minus little y equals m times big X minus little x. Our point was 311, so we just plugged that into our point values. And we figured out what the slope was, because if we're at 311, we just need to plug 3 into the derivative equation to find the slope, to find the m. So that 6 value replaced the m, and we were able to come up with the equation. So the next problem is this one, and we're going to do this one next. In fact, what you should try to do is go ahead and pause the video. Actually, I see I'm at 10 minutes, so I'll stop here. You should go ahead and try to do this one before I do it to see if you can get it. What is the equation of the tangent line at f of x equals x to the third? See if you can get it, and I'll see you in the next video. If this was helpful, please remember to like and subscribe. Thank you.